All right, so let's look at this section, which is sum and difference formulas again. It says find the value of the trig expression when sine u is 5 over 13 and cosine v is negative 3 over 5. Both are in quadrant 2. So we need to draw the coordinate grid. We got to do 2 because these are 2 different triangles, 2 different functions, 2 different graphs. So sine of u is y over r. So it's a right triangle in quadrant 2. Oh, I'm not going to do theta. Instead, I'm going to replace this with u. So 5 over 13. So we've got to find that missing side. So if you know your triples, Pythagorean triples, this would be 12. But since it's going negative, it's negative 12. Okay, and then the other one is cosine v. We're in quadrant 2 again. So we know this is x over r. So it's negative 3 over 5. So then another Pythagorean triple is 3, 4, 5. So this is going to be 4. So to help us along the way, because we are finding cosine u, we need to go ahead and find sine and cosine of both of these triangles. So for this one, I'm going to do sine of u is 5 over 13, which was a given. Cosine of u is negative 12 over 13. Then the other triangle, sine of v this time, is 4 over 5. And cosine of v is negative 3 over 5. All right, so that's going to help us as we solve this. So we know that this is found on our formula chart. It is cosine u cosine v. Since this is minus with cosine, we do plus sine u sine v. So because we worked this out already, we can just plug in. So cosine of u is negative 12 over 13. Cosine of v is negative 3 over 5. Okay, I'm going to put parentheses around that so that I remember what I need to do first. Sine u is 5 over 13. Sine v is 4 over 5. Okay, multiply fractions, top times top, bottom times bottom. So this is 36 over 65 plus 20 over 65. Add those up, we get 56 over 65. And that cannot be reduced. So this is our final value. So cosine u minus v is 56 over 65. Okay, let's go to example 2. Find the exact value of the trig expression when sine u is negative 7 over 25, cosine v is negative 4 over 5. Both u and v are in quadrant 3. So let's go ahead and draw. We're going to be in quadrant 3. So this is sine is y over r. Cosine is x over r. So here's our right triangle. This is u. So negative 7 and 25. Use Pythagorean theorem to find the x value. It's also Pythagorean triple, which is going to be 24, but since it's going in the negative direction on our x-axis, it's negative 24. Okay, and then cosine, let's go ahead and draw our triangle here. This is v, negative 4, 5. Another Pythagorean triple, 3, 4, 5. So this is negative 3. Okay, so we have our triangles. Now let's look at our formula, tan u plus v. So our formula for tan is tan u plus tan v over 1 minus tan u tan v. Okay, so in order to do this, I have got to do my tan for both u and v, and once I get that, then I'll be set to go. Okay, so tan of u is going to be negative 7 over 24, which comes out to be positive 7 over 24. Tan v is negative 3 over negative 4, which is positive 3 over 4. All right, so I have that. Now I'm just going to plug in. So this equals 7 over 24 plus 3 over 4. 1 minus 7 over 24 times 3 over 4. Okay, so now it's just a matter of dealing with all these fractions. So I would need to do a common denominator. So times 6. So it's 7 plus 18, 25 over 24 over, this would be, I could simplify, cross simplify by 3. So it's 7 over 32, 1 minus, well, I need a common denominator, so 32 over 32 minus 7 over 32, which is 25 over 32. With fractions, we are going to flip the second and multiply. Okay, cross cancel, 25 and 25. Okay, we have 24 and 32. I want to simplify that. I could go ahead and multiply because these are both 1 and get 32 over 24 and simplify that way. Or I could go ahead and look at how this can be simplified by 8. So this is 4 over 3. So that is our final solution. All right, let's verify the identity on this. So it says sine 3 pi minus x equals sine of x. So we need to make the left side equal the right side. The left side's a whole lot more complicated, so there's a lot more to do there. So we're going to do that. So this is subtraction with sine. So we use this as u, this is v. So sine of 3 pi cosine of x minus cosine. Let's look at our formula. Cosine of 3x sine x. All right, so since we have, oh, that's 3 pi, isn't it? Since we have 3 pi, we can go ahead and find out what that is and see if we can do something there. Because remember, we're wanting to equal sine of x. So I'm going to end up somehow canceling something, but I got to start somewhere. So let's do 3 pi. So this would be 2 pi. So this would be 3 pi, which is at negative 1, 0. Sine is y. So that is 0 times cosine x minus, what is cosine 3 pi? Sine is y, cosine is x. Negative 1 times sine of x. 0 times cosine x is 0. Minus a negative 1 sine x becomes positive sine x. Look at that. It worked. Just took that formula of subtraction. Okay, so let's look at this next one. We're going to work on the left side. That's more complicated. So sine of x plus y, sine of x minus y equals sine squared x minus sine squared y. So let's go ahead and transform that. So that's going to be sine x cosine y plus cosine x sine y times sine x cosine y minus cosine x sine y. All right, hopefully you recognize this as something like this. X plus 2 times x minus 2. It's a difference of squares. So this is going to end up being just our first and last term because the middle term zero out. So it's sine squared x cosine squared y minus cosine squared x sine squared y. All right, so let's see what we can do. So I want it to be all in sines. So I need to somehow get rid of this cosine. So let's think and look back at our Pythagorean identities. So sine squared u plus cosine squared u equals 1. So cosine can be found by doing 1 minus sine squared x. So we are going to replace cosine squared using Pythagorean theorem identity. So I'm going to keep the sine squared x, and I'm going to replace the cosine squared x. All right, so let's go ahead and distribute. So sine squared x minus sine squared. Ooh, I made a mistake. Wonder if you caught it. This should have been y. This one's x though, so that's fine. Okay, that should be y. And then I need to distribute this. So this is minus. I'm going to keep this in parentheses. Sine squared y minus sine squared x sine squared y. I forgot something right here. It should have been minus sine squared x sine squared y. And there's a minus between them. Okay, so then this, get rid of parentheses. And distribute this negative. Okay, so now look and see if there's anything we can cancel. We have sine squared x, sine squared y. We can't cancel those. But we do have a sine squared x, sine squared y together. One's positive and one's negative. So those zero out, leaving us just with sine squared x minus sine squared y. And that is what we wanted. And we will